Now let's move towards the concept of angular acceleration. Now for that you need to consider another figure, uh, this one, yes. So what is represented over here, that this rotor is rotating over here anti-clockwise viewed from here, okay, on x-axis. So this x-axis is the spin axis of this rotor. Now after few minutes or after few time, very less time, due to some reason, this axis is moved or rotated like this over here, okay. It is the plane xy. This is y axis, this is x axis. So the spin axis is rotated in xy plane somewhat at angle delta theta, okay. And when the rotor was rotating on x axis, the speed was omega, and when the rotor is rotating on x dash or x prime axis, the rotor is rotating at somewhat higher speed than the previous position, means delta omega. So the speed over here, or the angular velocity over here, is omega plus delta omega. So at after few time delta t, the axis has moved the few angle delta theta at somewhat few higher speed delta omega, means omega plus delta omega. So now what we want to represent uh, this case as vector representation, okay. Now let me show you that, okay. So from this figure we have drawn the vector diagram like this. So OA represents the magnitude of velocity omega, because this is, see, the length of the vector represents omega, right? After time t, small time delta t, sorry, it has moved to axis ox prime, that is represented by OB, right? Now the speed is increased, means omega plus delta omega. So you can clearly see that the length of the vector OB is more than the length of the vector OA, because it is somewhat higher speed, and the higher the speed, the more the length of the vector will be. So this is the vector representation. OA represents the OX, OB represents OX prime, right? Now we are interested in finding the angular acceleration. So what is that? That is change in angular velocity, that is called angular acceleration, right? So we can say that this closing vector AB is representing the angular acceleration, right? That because that is the change in angular velocity, that's the angular acceleration, that is AB, okay. So what if we want to find out what is the angular acceleration, what is the value total angular acceleration? So we need to uh, find out the value of, means the component of this vector, that are AC and CB. These are the components of this acceleration vector, okay, the vector represented by AB. So AC and CB are the two components of the vector AB. So if we find out these two vectors and add them, that will give me the total angular acceleration, right? So from this geometry of this figure, uh, this angle is delta theta, and you apply some trigonometry. So first let us start with AC, and that is if we want to know what is the value of AC, it is omega plus omega, sorry, omega plus delta omega cos theta minus omega. Now this is because, see, the component OC is omega plus delta omega cos theta, right? Because if you will apply, assume delta theta over here, what is cosine delta theta? It is a side upon hypotenuse, means what is the side? It is OC upon this OB. Now OC upon OB, right? So you can say that, so cos delta theta, if you assume delta theta over here, it becomes cos delta theta is equal to OC upon OB, right? So if you make OC as a subject, it becomes omega plus delta omega cos delta theta. But we don't need OC, right? We only need AC. So what is AC? It is OC minus OA, right? It is OC minus OA. So what is OC? It is omega plus delta omega cos delta theta minus OA. Now what is OA? That is the length of the vector. It is omega. So here it becomes AC is equal to omega plus delta omega cos delta theta. It is this one OC minus OA, that is equal to omega. So if we apply limit to this equation, uh, it becomes like that with respect to delta t. So it becomes like this, and after that, because cos delta theta is very small, so cos 0 becomes 1. That's why we can neglect it because it is in multiplication, and finally the equation becomes like this: AC is equal to d omega by dt, right? Now this is the component AC. Now what about the component CB? Okay, sine applying the applying sine delta theta over here, it becomes CB upon OB, right? Likewise, so as done in previous case, so it becomes like this. We apply a limit to that equation. It becomes like this. Now sine is now the delta theta is very small, so sine delta theta becomes delta theta. So the equation becomes like this, and finally we get CB is equal to omega d theta by dt. Now here you can say that why delta omega into delta theta is not considered, because if you multiply omega delta theta upon omega t plus delta omega into delta theta divided by delta t. Now this is because the multiplication of delta omega and delta theta will become so small that you can neglect that. That's why it is only considered that, that's why it is neglected, and only this residual term is kept over here. So the total angular acceleration will be addition of these two vectors, that will become alpha acceleration is equal to d omega by dt plus omega into d theta by dt. So this is the angular acceleration if the disk is rotated from here to here, means the spin axis is rotated over here to here. Okay, so that is your final angular acceleration. So this can be asked in examinations. Now what is this d omega by dt is representing? It is representing the change in magnitude of the angular velocity of the rotor. Okay, this d omega by dt, this term means this one AC, that represent the change in speed, means this much amount of speed is increased while changing the spin axis from here to here. This term represents that. Now what this term represents? The omega d theta by dt. That is representing the change in direction of the axis of the spin. Okay, so it is representing, this vector is represented by that. Okay, so it is representing the change in direction. So this is representing changing the change in magnitude, and this term is representing change in direction. Okay, so this amount of speed is increased and in this direction. Okay, so this is the conclusion of this theory. So hope you have understood. We'll continue the fundamentals of gyroscope in next videos. Thank you.